President and CEO of Potential Difference, Inc. Luc Choquette is our CTO. And Potential Difference Incorporated is an R&D company in Ottawa. And our primary area of focus with this innovation was initially looking for ways to reduce generator armature reaction. So as just anybody who doesn't know, just for the sake of the video, generator armature reaction is this. Here we have a generator, and right now I'm going to put it on no load. So here we have an electric generator at a load. When the electric generator is turning on idle, it's very easy to turn the generator. Okay? So will you turn the generator, and I'm going to place it on load. When the generator is placed on load and load current flows from the generator to the load, the generator creates a counter electromotive torque which resists the turning of the generator. So you have to apply more force to keep power to the load. So start turning it on imagine that you're on no load. Go ahead, turn it. So I'll put it on load here.
Yeah, it's harder.
So you can see that it's much harder. Now, when you're operating a generator that's supplying power to a load, the more power that you send to the load, the more additional power you have to put in once the generator is placed on load to keep the generator turning. Okay, the counter electromotive magnetic field that's produced inside the generator is called generator armature reaction. Okay, so initially our research looked at ways to reduce the magnitude of the magnetic field produced inside the generator to reduce the armature reaction and make the conversion of mechanical power to electrical power more efficient. Our research showed that when the load current inside the generator is delayed by 45 degrees, the generator armature reaction can actually be reversed. And this is what this demonstrator prototype is meant to show. In the demonstrator prototype, we have a conventional generator coil, and we have a regenerative acceleration coil. And what I'm going to do in the demonstration is I'm going to put the conventional generator coil on load with this small light bulb, and we're going to observe conventional generator armature reaction, and the sine wave that we'll be looking at on the scope is the current that's flowing through the conventional coil. Then I will engage the regenerative acceleration coils that are embedded inside the conventional coil, and we will observe regenerative acceleration. So that's the essence of the demonstration. We can get into the nitty-gritty of it later on, but what you will see on the scope is you will see in the yellow sine wave the current flowing through the conventional coil on load, and then we have a regenerative acceleration coil with the same light bulb, and you will be able to see, as you see in that diagram there, that the current flowing in the regenerative acceleration coil is delayed by 45 degrees, and this is what accounts for the acceleration under load.
So why did you put your glass?
It's old habit. Just old habit. I used to be a motor technician, and you weren't allowed to do anything with glasses, so it's just superstition. So I'm going to bring the prototype up to operating speed, which is about 3,000 RPM, before I do anything, and then I'll show you conventional generator armature reaction or electric vehicle regenerative braking, and then I'll show regenerative acceleration. So we're going to start with a drive shaft that is already decelerating. We want to make sure that there's no extra power in the drive shaft. So now I'm going to put the conventional coil on load. The conventional coil is on load. The conventional generator coil is creating the same counter electromotive torque that we saw in this. Now I've engaged the regenerative acceleration coils in the prototype. The prototype is accelerating. The power to the load is increasing, and we're basically in regenerative acceleration mode. This is the current in the conventional coil, and this is the current in the regenerative acceleration coil. So I'll put it back into regenerative braking mode. With the prototype in regenerative braking mode, because the generator is creating a counter torque, the prime mover is drawing increasing amounts of power to try to prevent the deceleration, and the prime mover is adding increasing amounts of torque to the drive shaft to prevent deceleration. When we go into regenerative acceleration mode, the paradigm is shifted. Now the prime mover is using decreasing amounts of power as the system accelerates, because the regenerative acceleration generator is creating a torque that is in the same direction as the prime mover. So if this was integrated into an electric vehicle, the electric vehicle's generator would be able to not really accelerate the vehicle down the road while it's recharging the batteries, but it would not cause regenerative braking in the electric vehicle while it's recharging the batteries, unless that was specifically desired.
Can we ask question now? Or you still have something to show?
That's about it.
Okay, so let's now put, you remove your system, understand now,
Cameraman.
you just control this engine. It's an engine, it's not, is it the same? No, it's not the same like this, right?
No, it's an induction motor.
It's another one, it's a motor. Okay, you turn this wheel.
Yeah.
And on the wheel there is some
Magnets.
magnets
Yeah.
to
Energize the coil.
this one here.
Yeah.
Okay. So this one is not, there's no power on it, there's no current.
No.
Not at all now.
No.
Okay. Now you're at 3,000. It's not going up or down. It's stable.
Well,
It's about stable.
yeah, it's going down a little bit.
So you measure the speed of this wheel.
Yeah.
And what's the current now in the engine? Can you see current?
It's 2 amps right now.
2.4.
Yeah.
So that's the current in this engine. Okay. And where can we see the current in this?
Well, there's no current. in it.
It's not activated right now.
There's no current now. Did you measure it?
Well, I can tell you it's not on load, so there's no current.
Okay. But when you put the load, you will see the current,
Yeah.
right? Okay. So now there's no current. Okay. Okay. So what's the thing behind it? You measure the RPM, okay, behind. So it's about 3,000. It's going down a
It's
little
going
bit.
down.
Okay. So now if you activate, so when you switch that,
The
what are
load.
you doing exactly? You're just
I'm just
closing the,
circuit between the conventional coil through the load.
so this load is connected to this coil. Okay.
See that?
Yeah. So now you activate. That connection again.
Yeah.
Okay.
So now we have 0.7.
0.7 amp out of the coil because you know of
Current
the,
is 2.8 now, it's okay.
and now their RPM is going
down.
down.
And the
The current is,
Okay, now you disconnected or you're connected
No,
now?
it's,
It should be up, huh? The RPM should go up.
no, if it's disconnected.
No, but when it's connected, when it's
Yeah, see, now it's going
Now
Okay,
down.
now it's connected. Okay, now the RPM is going.
Down.
down.
but I'm gonna put it in
This is the
regenerative acceleration
conventional
mode.
Okay.
So now the current is 0.83.
Okay.
The voltage across the load is 12.6.
Okay. Can you remove just the regenerative? Okay. So now it's without it.
Yeah, now the voltage is going down.
The voltage. This is the voltage
This is the
across
voltage across the load.
the load.
This is the current through the load.
Okay.
So,
From the coil there.
yeah.
Okay.
So now we're in regenerative braking mode in an EV,
Yes.
okay? Before it goes too low, I'm just gonna put it back and bring it up
So
again.
what are you doing now? President?
I just engaged, there's two regenerative acceleration coils embedded
Inside the one you put on the side.
Yeah.
That's the innovation. It's there. In
Well,
this
yeah,
coil, right?
And it's the magnetic connection between the regenerative acceleration coil and the conventional coil. Okay, so if I take it off load, okay, you can see that it's 10.6
Yes.
and going down.
Yeah.
When I engage the regenerative acceleration
Yeah.
coil,
For the phase shift on the
well,
signal.
just
45.
when I engage it, we collect the discharging flux
Yes.
from the regenerative acceleration coil
Okay.
into the core of the conventional coil. So you watch it go up
Yeah. Yeah.
instantly before the speed goes up. So we are collecting the flux from the discharging regenerative acceleration coil. We're using the discharging flux from the regenerative acceleration coil to accelerate the rotor and increase the output, obviously.
Because there's less friction, I would say, like magnetic.
I will explain how it all works once we get through
The
demo.
physical behind
Yeah.
it. Yeah. But that's the result you get.
This is the net result.
So have you quantified I would say the percentage of efficiency you get compared to